Hi, welcome to Solving Science. I always try to have something exciting to share, especially for my subscribers. And wow, today is going to be really exciting. I think this is a really exciting one. Water. Okay, firstly, water is a freak of nature. It's an oddity. In my latest research with expanse tension theory, I've charted 44 individual distinct paradoxes of water that makes it one of the most anomalous substances in the known universe. And I'm going to take you through in this video what some of those are, what expanse tension theory has to say about those 44 paradoxes, and if you wait with me and kind of bear with me through the science, of course, general expanse tension theory starts to offer resolution to these paradoxes. Well, how many of the 44? Well, actually, all of them. Okay, so bear with me. So I'm going to need my glasses on this one. So, water, the most familiar substance on Earth, H2O, but it expands when it freezes. It reaches its maximum density at 4 degrees Celsius, which is odd. Its compressibility behaves the wrong way around. Its heat capacity increases in regimes where it should decrease. Its surface tension is extraordinarily high, and it leaves all other hydrogen bond liquids usually 70-80% higher surface tension values. And it exhibits structural competition between two different liquid forms. So there are major paradoxes with water. Most substances get denser when they cool, but of course ice floats. Cooling usually makes things denser, but with water, cooling it down to freezing point, it becomes less dense, which is paradoxical in itself. The compressibility anomaly. Normally, as temperature decreases, liquids become harder to compress. But with water, it becomes more compressible when it's cooled and towards the supercooled regime, which is odd. The heat capacity anomaly. Heat capacity should decrease smoothly with cooling, but water increases in certain regime, and that implies enhanced structural rearrangement energy. Okay. Surface tension. So water has a surface tension of about 72 micronewtons per meter. And that's roughly 3 times that of other alcohols in hydrogen liquid bonded liquids. Now, expanse tension theory, if you've been following the channel, posits that there is an all-pervading, real, quantum field theory permitted, singlet scalar field, quantum field, which couples with Higgs portal, Higgs licensed mass, in continuous density dependent modulation. Now, the explanation for gravity is that mass resists expansion. There's a tension gradient where mass resists expansion, expansion happening up there. Mass resisting expansion, a tension gradient between the two, and that tension gradient triggers a reaction force. Now, that all-pervading scalar field is reacting to all Higgs licensed mass, and we've used it previously to explain the double slit experiment and the Richard Feynman glass paradox and galaxy rotations and lots of other anomalies where simple mass resists expansion, and with density dependence we can explain the anomalies, paradoxes and unexplained mysteries and phenomena of the universe. And now we're going to try and solve water. So expansion exists as a physical background, and it's a tension field, and those tension gradients trigger the reaction of how mass reacts to this background field. Tension gradients bias equilibrium states without changing molecular rules. So hydrogen bonding still behaves as chemistry dictates, but the equilibrium of the landscape based on the amount of density can change things. So if we apply this framework to water, at 4 degrees C, two competing structural regimes balance because the density condition bias changes sign. Surface tension becomes amplified because cooperative networks propagate tension gradients deeper into the bulk of the material, of water. The compressibility anomaly reflects enhanced fluctuation response near density conditioned bifurcation. Isotopic substitution preserves anomaly patterns because the coupling depends on density regime, not the isotope mass directly. Okay, sounds complicated. What does it mean? It means that of all the 44 paradoxes of water, they exist in thermodynamic, structural, interfacial, and electromagnetic domains. And if you assess them, it implies there's a cooperative sensitivity to water based on density gradient relevance. And it's plausible that the scalar field of expanse tension theory provides physical mechanism to the problem that we see. Now, in the paper that I will link to, I chart and catalogue the 44 paradoxes of water. I group and organise them into categories, and then I look to see of those categories how a density-dependent scalar field could trigger a particular sensitivity to this tension gradient. Okay, I'm not claiming that this is validated or proven in any way, shape or form. What the paper says confidently is, of the 44 paradoxes of water, it implies this sensitivity of water precisely. It might just be the perfect antenna for the Holland field, this scalar field that this coupling field. So water's anomaly clustering, one liquid that clusters so many paradoxes in one place, may reflect a deeper density conditioned equilibrium bias. Okay, think about that. Water might just happen to be the perfect conductor antenna to display density dependence. It might not be strange by accident. It's amplified by this cooperative behaviour. Now, water is a freak of nature. I think it's fascinating. How amazing that water deviates and contradicts all the major basic physical ideas of the universe by cooling things and they get less dense, which is bizarre, and why a certain maximum density occurs at a random temperature point within the liquid phase, not a transition phase. So I'll link to the paper. If you're interested in why water is weird, in what ways are it weird, so you get to know what is strange and weird, paradoxical about water, and you'll see the grouping and clustering of these issues and how a density-dependent scalar field might just provide a key to why water behaves as it does. And remember, this is, as water, a hydrogen-bonded liquid, differs from all the other hydrogen-bonded liquids, which you would assume would be quite similar in behaviour. You see those catalogues and you see the tables that I've built into the report showing how other hydrogen-bonded liquids do not operate and do not display these paradoxes of water. So water, it's an oddball, it's a freak. Please take a look at the paper. I think it's really interesting. You know, water is odd everywhere. Okay, thanks for listening. Please subscribe and watch the channel. Let's keep trying to solve things with expanse tension theory. Okay, bye-bye.